Before talking about exploitation, let's perform a vulnerability scan to our target systems so we are able to interrogate the vulnerabilities to exploit. Right, so let's review the phases of a penetration test. Putting reporting aside, a penetration test briefly consists of 5 phases. Reconnaissance is the act of gathering preliminary data or intelligence on your target. The data is gathered in order to better plan for your attack. The phase of scanning requires the application of technical tools to gather further intelligence on your target, but in this case, the intel being sought is more commonly about the systems that they have in place. A good example would be the use of a vulnerability scanner on a target network. Exploitation phase requires taking control of one or more network devices in order to either extract data from the target or to use that device to then launch attacks on other targets. The purpose of the post-exploitation phase is to determine the value of the machine compromised and to maintain control of the machine for later use. The value of the machine is determined by the sensitivity of the data stored on it and the machine's usefulness in further compromising the network. And the final phase, covering tracks, means simply that the attacker must take the steps necessary to remove all semblance of detection. Any changes that were made, authorizations that were escalated, etc., all must return to a state of non-recognition by the host network's administrators. Nessus, developed by Tenable Network Security, is one of the most popular and capable vulnerability scanners. Nessus Professional is a commercial product. In addition, a free Nessus Home version is also available, though it's limited and is only licensed for home network use. And we're going to use the Home Edition. Now, Nessus is not embedded into Kali, so let's download it to install and use in our Kali. Open the browser and search for Nessus Home Download in Google. I think you already know that Nessus Home is the name of the free version of Nessus. So discard the ads. The first link is Tenable's Nessus homepage. We need an activation code to use Nessus Home, and we have to register for an activation code. So you'd better register with your exact names and email addresses. Since I have previous registrations, I'd like to register with a public name and mail address. Ethical Hacker is the name and surname. ethichack@yopmail.com. Click register when you're okay. Now the next page is where you can find the download link for Nessus Home. The page says that an email containing my activation code has been sent to my email address. So let's open a new tab and look to see if we've got the activation code. I go to yopmail.com/ethichack, which is the URL address of ethichack@yopmail.com email address. And here's the email with the activation code. Now go back to the homepage of Nessus and click Download. Here's a list of the binaries of Nessus Home. Our Kali is a 64-bit Debian, so I'm going to click and download this one. And save the file. Now let's install the packet that we downloaded. I go back to the browser to see the location to where the file has been downloaded. It's downloaded in the Downloads folder. Now open a terminal screen and go to the folder using cd command. To install the packet, use dpkg Linux command with iparameter. And last, type the file name. Remember, you can use the tab key to complete the file name and hit enter. The installation is completed within a few seconds. Now let's look at the messages. It says we should start the Nessus D daemon to start Nessus Home. And then we can connect to the web interface of Nessus, which will be served at port 8834. This is the default port of Nessus Home's interface. So use the service command to start the Nessus D daemon. First, I want to look at its status. It's inactive at the moment. Type service Nessus D start to start Nessus D daemon. Now, let's look at the ports of our Kali, which happen to be in listen mode. Use the netstat command with TNLP parameters. And here it is. Port 8834 is being listened to by Nessus D. Now we can access Nessus Home's web interface. So go to the browser and type 127.0.0.1:8843 and hit enter. As you know, 127.0.0.1 stands for the local host. You can use the IP address of your Kali instead. It doesn't matter. Whoops! Nessus service is an HTTPS service. So we have to use HTTPS at the beginning of our URL. So our browser says that the connection is not secure because the local certificate of Nessus is not registered by a CA, a certificate authority. No worries, click Advanced and then Add Exception and click Confirm Security Exception. And here's the first interaction with Nessus Home's web interface. So the next step is to set up Nessus Home. First step is to create an account. Select a username for yourself and add a password. Click Continue. The next screen asks the scanner type and the activation code, which has been sent to our email address while we were downloading the Nessus Home's installation packet. Here are the scanner types. We'll use Nessus Home, so leave the first option selected. Now I go to the email sent by Nessus and copy the activation code and paste it into the related field. Then click Continue. As soon as setup is complete, Nessus downloads and initiates the latest plugins, which will be used in the scans by Nessus. First, it downloads the plugins according to your connection speed. Now, it may take a few minutes, so be patient. Now it's compiling the plugin. This step may take longer than the download step, so you might want to go and grab yourself a cup of coffee. And there it is. The initialization phase is complete. Welcome to the Nessus interface. Now let's perform a vulnerability scan using Nessus Home Edition. I want to perform an aggressive scan to find as many vulnerabilities as possible. Go to Kali and start the Nessus daemon if it's not already started. Use service Nessus D status to learn if it's running. Okay, so it's inactive. So I use service Nessus D start to start Nessus service. Now, go to your browser and connect to the Nessus interface. It is a HTTPS service. It's running on the same machine, so I'll use 127.0.0.1 loopback IP address referred to as localhost, and the port of the Nessus service is 8834. Sign in using your credential. Click the New Scan button. Now let's choose Advanced Scan for this scan. Will be more aggressive than a basic network scan. So enter the basic info, give the scan a name, and enter a description if you want. And the targets. Here I have a Windows XP with an IP address of 207 and Metasploitable 2 Linux system with an IP address of 206. Here I have a third system, an up-to-date Windows 8, and its IP address is 223. Right, so back to Kali and enter the IP addresses of the target systems. 206 for Metasploitable, 207 for Windows XP, and 223 for Windows 8. Now click Discovery in the list at the left. So we're simply going to accept the defaults on this page. So let's click on Assessment over to the left. And on this page, we want to check Perform Thorough Tests, so check the box. Then move to the Report section in the options on the left. You can override the normal verbosity to make it report as much info as possible. So next, click the Advanced option in the list to the left. The only thing we're going to do here is uncheck Enable Safe Checks. Now, on a normal production network, you would leave this box checked. You don't want to take down production systems when scanning. But for our purposes here, we want to gather as much information as possible, so we're going to uncheck it. Now click on the Credentials tab. Select the SSH option in the list on the left. Now, since we know the username and password for the Metasploitable 2 machine, we're going to put those credentials in here. Remember, the username and password are both MSF admin. Change the authentication method to password and put in the username and password below. Now, in the Plugins tab, we only need to activate the plugins that have to do with what might be running on a Linux system, so we can disable a few things here. Okay, I paused the demo here. I've got to make an apology. It's a late update. While capturing the demo, I forgot that I have Windows targets and disabled the Windows plugins. It's a mistake, and I just wanted to show you that what we do here is, if there's a problem, there's always a solution. So if you have Windows targets, please do not disable the Windows plugins. All right, let's move on. We can finally click Save at the bottom. So here's the scan, and we're ready to run it. Simply click the great triangle at the far right of our scan, which stands for launching the scan. And yes, the scan is started. Now you can pause or stop the scan anytime you want. So click the scan, and we see the results in real time. Okay, boy, that's going to take a while to run, so it's probably a good time to check your email, grab a cup of coffee maybe, but just make sure you come back to review the results. So the scan is completed in 17 minutes. Now another pause here. Because I disabled the Windows plugins, it seems as if the Windows systems don't have critical vulnerabilities. It's not right, especially my Windows XP has several critical vulnerabilities. If you didn't disable Windows plugins, you're supposed to see some more vulnerabilities for Windows systems. Now, to see the results of the Metasploitable scan in detail, let's click the Metasploitable Results 206. The Nessus Home found 10 critical vulnerabilities with our scan configuration. But please note that the configuration affects the results, so the target systems may have more vulnerabilities than reported. If there is a vulnerability and it's not found in a scan, we call it a false negative. Now, I'm sure you know that the critical vulnerabilities are the most dangerous ones. But that's where it gets good. They are the most exploitable ones in general. So let's click on one of these critical vulnerabilities, for example, bind shell backdoor detection. Well, look at the description. It says a shell is listening on the port without any authentication being required. This is obviously a backdoor. Here's a port number, 1524. Now, let's check if the finding is a true positive. Go to terminal screen. I use Netcat tool to connect. Simply type NC and the target IP and the target port 1524. And we're in. We have the shell for Metasploitable. Type who am I to learn the credential we have. We are the root user. Now, it was too simple. It's just not fun. And, I don't like it. I like a good challenge, right? We are the root user, and we can access anything we want. For example, shadow file, which contains the hashes of the user's passwords. Okay, back to the browser and click on the Back to Vulnerabilities link to turn back to the vulnerabilities of Metasploitable. Now I'd like to show you some more. Scroll on down the vulnerabilities. It shows 50 vulnerabilities per page by default, but let's make it 200 to see all the findings in a single page. Now, the findings are ordered by severity levels, so information is at the bottom. Findings with a severity level of information identify non-vulnerability information, which is, nice to know, and it keeps it separate from the vulnerability detail. So here there's an info RMI registry detection. Let's click it. It says that the remote host is running an RMI registry, retrieving remote objects in the Java runtime method invocation system. So let's look for the exploits of the Metasploit framework, if there is any exploit for Java RMI. Open a terminal screen and run MSF console. So here we have MSF console. Let's search the exploits of RMI. Too many results. To keep it more specific, I want to search Java RMI. So we have 2 auxiliaries and 2 exploits at this time. So look at the exploit in the last line. This module takes advantage of the default configuration of the RMI registry and RMI activation services, which allow loading classes from any remote URL. Let's try to use it on our RMI port. Please don't worry, I am going to explain what these all mean. I just want to show you an example at the beginning, so bear with me. Type use at the module name with the full path. You can simply select the module name and click the middle button of the mouse to copy and paste it. Type show payloads. To see the payloads can be used with this module. So I want to use this payload to have a Meterpreter session. Again, don't worry, I'll explain what the Meterpreter is soon, but just copy and paste the payload name. Type show options to see the parameters of the exploit and the payload as well. Set the remote host as Metasploitable 206. Default remote port is the same with our port 1099. Serve host is the local host to listen on. Set this to be our Kali 222. Let the default serve port remain. So the other options are not required. I'll just leave them blank. Now are the payload options. Set the listen host to be our Kali 222. Default listen port is good, 4444. And finally type exploit to run the exploit. So there, it looks like we have a Meterpreter session. Type sessions-L to list the active sessions. Be patient, we'll see them in detail. Type session-I, session ID, to interact with the session. And here we are, we're in. Now I'm going to show you what we can do with a Meterpreter session in the following chapter. But here's a couple of Meterpreter commands. sysinfo to see the system information. Hashdump to gather password hashes. Now, no such command for this system. Thankfully, we have an alternative for this. Type runpost/linux/gather/hashdump and hit enter. And collect the fruits of your labor. So, as you see here, we found another way to exploit the system, even though the finding was just information. So, I hope you understand not to underestimate any finding. Okay, everybody, I admitted I made a mistake in a previous scan, and I disabled the Windows plugins, although 2 of my 3 targets are Windows. It's just a really big mistake that affects the results, so that clearly shows that we should be very careful while configuring the tools, such as the vulnerability scanner. Now, I scanned the target machines once again, and I didn't disable the Windows plugins this time. So these are the results. 207 is Windows XP, and 223 is Windows 8. I click on the Windows XP to see the vulnerabilities. And as you see, there are a lot of critical vulnerabilities. I'll click on one of them just to see its details. So here is the name and the description about the vulnerability. And scrolling down, yes, it says the vulnerability is exploitable with Metasploit. Let's go back to vulnerabilities. I want to show you another vulnerability for our XP system. This is the vulnerability MS08-067, which has a very stable exploit. Rolling down a bit, and Nessus says we can exploit this vulnerability using Metasploit. So let's do it. I think it's an invitation. Open a terminal screen and start MSF console. Search for the vulnerability MS08-067. Here's the exploit. Let's use it. Look for the available payloads using Show Payloads. I want to use shell payload with bind TCP stager for this time. Show options. Set the remote host that was, well, let me look at the Nessus page again. Yes, 2007. And the port is 445. The default value is correct. Show the options again, and we're ready to run the exploit. Here is the shell of the target system. Exploitation is successful once again. Now, to understand what we'll do throughout the course, I think it's better to start to learn the exploitation concept and the terminology. So literally, an exploit should be defined as a piece of software or a sequence of commands that takes advantage of a vulnerability to cause unintended or unanticipated behavior to occur on computer software or hardware. But I'd like to explain it in these words. An exploit is an attack on a computer system, especially one that takes advantage of a particular vulnerability the system has. Such behavior frequently includes things like gaining control of a computer system, allowing privilege escalation, or a denial of service attack. Used as a verb, exploit refers to the act of successfully making such an attack. Now, you heard me use the word vulnerability. I think we should clarify that a little. A vulnerability is a flaw or weakness in systems, designs, implementations, or internal controls that could result in a security breach or a violation of the system's security policy. In the context of cybersecurity, the payload is the portion of the malware which performs malicious action. An exploit is used to run a payload on the target. The things we could do on the target depend on the payload. A payload may give you a shell at the target, an access to the password stored on the target computer, a backdoor on the target, etc. Payloads are usually written in assembly language, and they are usually platform dependent. In other words, you may not use a payload written for Windows on a Linux system. So let's explain the vulnerability, exploit, and payload terms with an example. Here we have a missile, and here is the target. Well, I think the vulnerability is obvious. An umbrella wouldn't be enough to protect a guy, right? Missile with a rocket, fuel, everything else, and then it has a warhead on top that does the actual damage. So the missile is the delivery system, and that's the exploit. The warhead is the payload that actually does something to the target. All right, so because you force the systems to work in unintended ways, there are always some risks while performing penetration tests. And it's probably obvious, but exploitation and post-exploitation phases are the most risky parts of any penetration test. We can classify the risks as follows. Especially the legacy systems and custom applications may be taken offline by an automated vulnerability scanner or overabuse by the attacker. Likewise, servers may be out of service. Based on the amount of the automated scanning, the size of the network pipes, and the number of ports on a particular system, it's possible to overwhelm a service or medium, resulting in performance loss. You may unintentionally or intentionally cause configuration changes while trying to exploit a vulnerability. Now, it's very common for a penetration tester to access the confidential data of the institute. So watch out. Please be very careful with the data that you collect. Now, you may have some tunnels or backdoors, especially in post-exploitation. It's a big risk to forget to clean them up at the end of the penetration test. But don't worry, all the exploitations and post-exploitations will run at the memory of the target systems. So the backdoors or the tunnels are deleted when you shut down the systems. So to help mitigate the risks, many approaches can be taken, and I'll give you a few examples. Exclude legacy systems and custom applications from automated testing. To ensure security, perform manual testing of excluded items. Perform testing of critical systems during off hours. Critical systems can be scheduled for testing during low-volume business or off-business hours. Perform testing in a phased manner, starting with user acceptance testing, UAT environments, to ensure the actual tests do not affect particular systems or networks. Once UAT is complete, then begin testing on production environments. Set up monitoring and escalation procedures prior to testing. Ensure fault management is in place to ensure systems send alerts when they go down. Ensure proper phone numbers and other contact information is defined to immediately investigate and restore services in the event of a problem. Escalation procedures should include contact information for the person performing the test so they can immediately stop all testing if required. Now, you've got to throttle back automatic testing to use less bandwidth to help prevent bandwidth issues. Also, the number of ports can be reduced if there's a concern for overloading a particular group of systems. Usually, it's recommended to test the UAT environment instead of reducing the number of ports because certain vulnerabilities may be missed. And always have a cleanup procedure to reverse the modifications of configurations, to delete users created during the test, to remove the backdoors, etc., etc. The exploits and the payloads that the exploitation frameworks use work in the memory in general, and that means they are not permanent, and the backdoors and tunnels are terminated when the memory is cleaned. So let's talk some about exploit databases. The exploit database is the ultimate archive of public exploits and corresponding vulnerable software developed for use by penetration testers and vulnerability researchers. Its aim is to serve as the most comprehensive collection of exploits gathered through direct submissions, mailing lists, and other public resources, and present them in a freely available and easy-to-navigate database. An exploit database is a repository for exploits and proof of concept rather than advisories, making it a valuable resource for those who need actionable data right away. The most famous exploit database is exploitdb.com. It's a CVE-compatible database, and wherever it's applicable, CVE numbers are assigned to the individual exploit entries in the database. Okay, so I said CVE-compatible, but what the heck is CVE? The abbreviation of the Common Vulnerabilities and Exposures. CVE is a list of information security vulnerabilities and exposures that aims to provide common names for publicly known problems. The goal of CVE is to make it easier to share data across separate vulnerability capabilities, like the tools and the repositories and services with this common enumeration. See, we're all working together. Now, another example of exploit databases is PacketStorm. And PacketStorm provides around-the-clock information and tools in order to help migrate both personal data and fiscal loss on a global scale. As new information surfaces, PacketStorm releases everything immediately through its RSS feeds, Twitter, and Facebook. Before going deep on exploitation frameworks, let's see how we can find and run an exploit manually. Because it's not the subject of the course, I'll not show you how to develop an exploit, but we are going to use the exploit from exploit databases. So in this demo, let's say that we think that the target system has the MS03_026 vulnerability. To exploit the vulnerability, we'll follow these steps. First, we'll search for the exploit MS03_026. Then, compile the code. If there are errors in the code, we have to find and fix the errors, or find another exploit. And finally, we'll run the exploit. Now, if we're lucky enough, we can successfully exploit the target system and have a command shell on it. So go to Kali and open a web browser. Type exploitdb to search for the exploit database. I click the first link, which is exploitdb.com. Now click Search at the upper right-hand corner. Write MS03_026 in the search bar. And prove that you're not a robot, and click Search. We found 3 exploits in the database. So let's try the oldest one, which is developed by H.D. Moore, who is the developer of Metasploit framework, by the way. So click the link. And here's a source code of the exploit. So let's download the code and save the code to Kali. Now open a terminal screen and go to the folder where the exploit code is downloaded. And here's a source code, 66.c. It's a source code of C programming language, and we can compile it using the GCC compiler. The GNU Compiler Collection, GCC, is a compiler system produced by the GNU project, supporting various programming languages. GCC is a key component of the GNU toolchain and the standard compiler for most Unix-like operating systems. Originally named the GNU C compiler when it only handled the C programming language in the first release. Then it was extended to compile C++, Objective-C, Objective-C++, Fortran, Java, Ada, and Go, among others. So anyway, type GCC, give the source file name, and then output file name with -o parameter, and hit enter. Use the ls command to see the file produced. Here it is. GCC compiled and produced an executable binary file. Type // in the file name to run the executable, and it shows the help by default. Hey, good for us. See, because here we learn how to use the executable. The first parameter is target ID, so we have to learn the target operating system. And we can use Nmap, the network mapper tool, to interrogate the operating system of the target. Now, I'm not going to tell you more about Nmap here because it's the subject of the network scanning course. You can find out all the details of Nmap in my Network and Vulnerability Scan for Hacking by Nmap and Nessus course. Well, that's the end of the advertisements. Let's create the Nmap query. -SV for version detection, -O for the operating system detection. Now is the target IP and top 10 ports to scan. Here are the results. Our Nmap query says that the target operating system is either Windows 2000 with a service pack 0 to 4 or Windows XP with a service pack 0 or 1. We can try the result set one by one, But to keep it quick, let's look at the target system. So here's the target system. Right-click My Computer, select Properties. The system is Windows XP with Service Pack 1. Okay, so back to Kali. Let's remember the usage of our exploit again. Now, first parameter is target ID, and it's a 6. Second parameter is the target IP, which is 172.16.99.207 for me. And yes, we got the shell from the target system. So let's look at the IP address. It says 207, so I'll go to the target system to check if it's true. So I'll open a command line, type ipconfig, and yes, the IP of the target is 207. Let's turn back to Kali now and type exit to close the shell. Now look at the target system. As you see, the system crashed. All the exploits may have had some side effects, so you better test it before using on the live systems. And now, if I'm reading your mind correctly, I'm hearing that, boy, wouldn't it be better if we could go faster? And yes, you're right. Automation is the key factor to speed up the penetration tests. But first, let's learn more about the exploitation frameworks. In the previous lecture, we found the exploit code and exploited the target system manually. So let's list the difficulties of running the exploit codes manually. You have to manually find out the appropriate exploit code. In most cases, there will be more than one exploit code for a vulnerability, and you've got to choose the ideal one. You have to compile the exploit code with the right compiler and fix the compilation errors and bugs yourself. In most cases, you have to find the operating system and its version to apply the correct exploit. Exploit code may not be stable and may cause some denial of services. You remember our manual exploitation experience. The target system was inadvertently shut down after the exploitation. All the exploit codes run with a single payload. Dynamic payload usage is not possible. To be able to use another payload, you have to change the exploit code, change the payload, recompile the code, and exploit the target system again. So to get rid of all these difficulties, the exploit frameworks come in to help. Now with these tools, you don't need to find and compile the appropriate exploit codes, and you can dynamically use different payloads with an exploit, etc. So what are the exploit frameworks? Good question. One vulnerability is oftentimes the only necessary piece needed to gain a foothold in an environment. As an example, a network could be compromised due to a vulnerability found in out-of-date office productivity software, a PDF viewer, or even a browser. Exploitation framework tools contain capabilities to detect and exploit these particular vulnerabilities. The vendors of these software packages are continually adding exploits to their platform. Internal security teams and malicious actors alike can use the same tools to detect and exploit vulnerabilities. As some of the software exploitation tools are free, the bar of entry is minimal and can open up organizations to easy-to-perform attacks. So let's see a few examples of these exploit frameworks. Core Impact isn't cheap. Be prepared to spend at least $30,000, but it is widely considered to be the most powerful exploitation tool available. It supports a large, regularly updated database of professional exploits and can do neat tricks like exploiting one machine and then establishing an encrypted tunnel through that machine to reach and exploit other boxes. Canvas is a commercial vulnerability exploitation tool from Dave Itel's ImmunitySec. It includes more than 370 exploits and is less expensive than Core Impact or the commercial versions of Metasploit. It comes with full source code and occasionally even includes zero-day exploits. Now, throughout this course, we're going to use Metasploit framework. So let's get started.